A very warm good morning to all of you. This is Maria Pushpam, and for today's class, we are going to see types of error analysis and the methods how to detect and eliminate the errors present there. So, in the syllabus, what is given there is types of errors, random and systematic errors, methods of detection and elimination of systematic error, students t-test, confidence level, and q-test for rejection of results. So these are the topics we are going to see for today's class. Hope you are able to follow the previous classes, and now I'll start with types of errors. Types of errors. So there are two types of errors which affect the experimental result. So if you take the experimental result, it is being affected by two types of errors. One is called as determinate or systematic or constant error. Commonly it is called as systematic error. And second one is indeterminate or random or accidental error. Okay, so there are two types of errors. One is called as determinate error, another one is indeterminate error. So we can see one by one. First we can see what is it to be determinate error. So what I mean by determinate error is it's nothing but it's an error whose source can be determinable. It can be determined. The source of this type of error can be determined is called as determinate error, and they can be avoided if we are taking proper care. If you are taking proper care, these errors can be avoided. And these errors are said to be definite or it's said to be a constant value. So I'll repeat what is determinate error. So determinate error is a error which can be identified in the source. Second one, it can be minimized if care is taken. Third one, it has a constant value. So this is said to be determinate errors. Okay. So next one, indeterminate error. So coming to indeterminate error, or it's otherwise called as random error or accidental error. So these are error. From the word itself you can identify these errors or accidental errors are errors which cannot be determined the source. We can't determine from which source this error has come, and this is because it follows a random distribution of the experimental result, and these errors arise when the analyst has no control over the measurement. Mainly vibration during the weighing of the object causes erratic results. So these are the things said to be indeterminate error. So what do you mean by indeterminate error? It means these errors are errors whose sources cannot be predicted or determined. Then if you see the thing, there will be the errors are found in a random way in the experimental thing. Okay. Thirdly, the analyst doesn't have any control over this indeterminate errors. Finally, if there is a small vibration in the weighing object, the result will be abrupt. Its worst result will be coming over there. So these errors are called as indeterminate errors. So I think you are clear with determinate errors and indeterminate errors. I'll repeat. So what I mean by indeterminate error means the errors whose sources are determinable and they can be minimized, and indeterminate errors, these errors cannot be, the sources cannot be detected or it cannot be predicted, and it cannot be minimized very easily. Next we can see what are the different types of determinate errors or systematic errors. So there are three types of determinate errors. The first one is instrumental error, second one is operative error, and third one is methodic error. I'll repeat. So three types of determinate errors. One is called as instrumental error, second one is called as operative error, and third one is called as methodic error. Is it clear? So I'll go with instrumental error. So what, from the word itself you can understand what is instrumental error means. If there is defect in the instrument or the glass where this type of error will come. So instrumental error is mainly due to defective instruments or defective glasswares. Example we can see arms in unequal balance arms of unequal length and weight. Then if weight and balance arms are said to be rusted, incorrectly graduated burette, pipette, etc., then improperly calibrated weights and instruments with incorrect scale division. So these are the examples of instrumental errors. Mainly in our lab, if you see, if the graduation is not found to be proper in the burette, you can't find the reading correctly in the burette. Then coming to the weighing balance, if the pan or the thing is said to be rusted, it is said to be not calibrated properly. If you take a weight, the weight won't be an accurate weight. So this is said to be instrumental error. So how to overcome this instrumental error is, நம்ம என்ன பண்ணலாம்னா, what you have to do there is, you have to calibrate the apparatus and the glasswares periodically. For 2 months once, 1 year once, what you have to do is, you have to calibrate the instrument and check whether it is giving the correct reading. If it is not properly giving, means you have to replace it by another one. So by a proper calibration, you can avoid this instrumental error. Is it clear? So I'll repeat. So instrumental error is nothing but error caused to because of defective instrument or glassware. நம்மளோட இன்ஸ்ட்ருமெண்ட் ஒரு கிளாஸ்வேர் டிஃபெக்டிவாக இருந்துச்சுன்னா நம்மளுக்கு இந்த மாதிரி இன்ஸ்ட்ருமெண்டல் எரர் வந்து வரும். ஸோ மெயின் எக்ஸாம்பிள் பார்த்தீங்கன்னா நம்ம என்ன சொல்கிறோம், ஈஸியாக சொல்கிறது பார்த்தீங்கன்னா, யூ கேன் டேக் நாட் ப்ராப்பர்லி கிராஜுவேட்டட் burette and if the pan, உனக்கு தெரியும் வெயிட் எடுக்கும்போது கீழே அந்த பேலன்ஸில் பேன் இருக்கும், அது மாதிரி ஆமும் இருக்கும். ஆமும் ரஸ்ட் ஆகக்கூடாது, பேனும் ரஸ்டிங் இஸ் நத்திங் பட் கொரோட் ஆகாமல், ஏன்னா துரு போயிட்டுனா அது கரெக்டாக இருக்காது. ஸோ திஸ் இஸ் செட் டு பி இன்ஸ்ட்ருமெண்டல் எரர். Is it okay? So if you do proper calibration, this type of error can be avoided. Next one is said to be operative error. So what do you mean by operative error is nothing but it's an error caused due to the operation or the personal observation. It's otherwise called as personal error. நம்ம ஆப்ரேஷனை பண்ணுற ஆளோ அல்லது நம்ம ஆப்ரேஷனோ வந்து தப்பாக இருந்துச்சுன்னா this type of errors will come. So this is called as personal error and this is mainly caused because of operation and personal observation. Is it okay? So the example here is burning of sample during dissolution and heating. Then insufficient washing, drying and cooling of precipitate. Then weighing hygroscopic material in open air. Weighing hygroscopic material in open air na enna, it's nothing but hygroscopic material itself, it will absorb water. So if you weigh the thing in an open space, what happens? The weight will be changing. So operational error will be there. Then disability of the analyst to differentiate colors. நமக்கு வந்து டைட்ரேஷன்லாம் பண்ணும்போது நீங்கள் கலர் வந்து கரெக்டாக பார்க்கலன்னா உனக்கு என்ன ஆகும், எண்ட் பாயிண்ட் வந்து தப்பாக வரும். ஸோ திஸ் இஸ் செட் டு பி ஆப்ரேட்டிவ் error. Then observation of burette reading with parallax error. இது நம்ம நிறைய அப்சர்வ் பண்ணியிருக்கோம். While doing volumetric analysis, what we are used to do there is, we have to take the burette in the hand and keep in the eye level and see the reading. ஏன்னா நமக்கு ரீடிங் ஐ லெவல் வச்சு பார்த்தா தான் கரெக்டாக, தட் இஸ் டு பி, நம்ம ஐ லெவலில் வச்சு பார்க்கலன்னா வில் ஹாவ் அ ராங் ரீடிங் தேர், பிகாஸ் தட் இஸ் கால்ட் அஸ் parallax error. உனக்கு ரீடிங் குறைவாவோ கொஞ்சம் கூடுதலாகவோ தெரியும். ஸோ தட் இஸ் டு பி parallax error and committing arithmetic mistakes. நம்ம calculate பண்ணும்போது தப்பு போடுறது. These are said to be operative error. So how to avoid this operative error is proper operation as well as observation has to be made. So நம்ம ப்ராப்பராக ஆப்ரேஷன் பண்ணிவிட்டு நம்ம அப்சர்வ் பண்ணுறதும் ப்ராப்பராக பண்ணோன்னா we can avoid this operative error. So you can understand this operative error, I think. Is it clear? So first error we have seen is nothing but instrumental error. Second error is nothing but operative error. Now the third one what you are going to see is said to be methodic error. So what do you mean by methodic error? The method itself, it is wrong. If you are going with the wrong experimental method, the whole thing will undergo mistake, and that we call it as methodic error. So this error is caused because of faulty experimental method. நம்ம தப்பான மெத்தடை ஃபாலோ பண்ணோம், எக்ஸ்பெரிமெண்ட்டுக்கு தப்பான மெத்தடை வந்து ஃபாலோ பண்ணோம். ஃபார் எக்ஸாம்பிள், இஃப் யூ ஆர் டூயிங் டைட்ரேஷன் பண்ணும்போது நீங்கள் டோட்டல் ஹார்ட்னஸ் எல்லாம் பண்ணியிருப்பீங்க. ஸோ பஃபர் ஆட் பண்ணிவிட்டு தான் நம்ம என்ன பண்ணுவோம், வி யூஸ் தி இண்டிகேட்டர் யூஸ் பண்ணதுக்கப்புறம் பஃபர் நீ ஆட் பண்ணேன்னா உனக்கு மொத்தமே என்ன ஆகிடும், தப்பாக வரும். ஸோ தட் வி கால் இட் அஸ் மெத்தடிக் எரர். சிஸ்டமேட்டிக்காக போகணும். So this is said to be methodic error. So what is the example here is use of improper indicators in titrometric analysis, then co-precipitation gravimetric analysis, and loss of weight of precipitate due to solubility in the wash solution. Then it's also because of incomplete reactions. These are the main reasons for மெத்தடிக் எரர். ஸோ மெத்தடிக் எரர்ஸில் எப்படியெல்லாம் ப்ராப்ளம் வரும்னா, கரெக்டான இண்டிகேட்டர் நம்ம யூஸ் பண்ணாமல் இருந்தால் வரும். அதுக்கப்புறம் பார்த்தீங்கன்னா கோப்ரெசிப்டேஷன். நீங்கள் வந்து செகண்ட் இயரில் வந்து யூ ஹவ் டன் யுவர் analysis. That is nothing but cation and anion analysis you have done. If you are not properly using the chemicals, for the fourth group element will come in the second group. That we call it as co-precipitation. So this precipitation has to be avoided if you do the method in a systematic way. And the addition la proper நம்ம H2S கரெக்டாக HCl ஆட் பண்ணிவிட்டு ப்ராப்பராக H2S ஆட் பண்ணோன்னா your second group will be recovering. If you are not doing properly, fourth group element will also come in the second group. So this we call it as co-precipitation. So because of these things, this error will come. This error is called as methodic error. So how to avoid this methodic error is you have to follow proper condition while doing the experiment. So while doing the experiment, it's a very serious error, and how to minimize this error is you have to take care while doing the experiment. So this can be avoided only by doing properly the experiment. This error can be avoided. So this error we call it as methodic error. It's clear? So 3 errors we have seen. Initially, experimental results, there are 2 types of errors. One is said to be indeterminate or systematic error. First one is determinate or systematic error. Second one is indeterminate error. It's otherwise called as random error. So coming to determinate error, we have 3 types: instrumental error, operative error, and methodic error. Now we will go with the analysis of experimental results. Okay. So we have done all the experiment properly and we have done the thing. Now we need to check whether the result we have observed is correct or wrong. So there are 3 ways for determining the result. First one is student's t-test. Second one is confidence limit. And third one is called as q-test. I'll repeat. So first one is said to be student's t-test. Second one is confidence limit. And third one is q-test for rejection of result. So these are the 3 different analytical methods to avoid whether the result is found to be correct or wrong. You can check whether it is right or wrong by using these 3 methods. I'll repeat the method once again. First one is called as student's t-test for significance of result. Second one is said to be confidence limit, and third one is said to be q-test for rejection of result. We can see one by one. First one is student's t-test for significance of result. So how we have to do this is you have to do a series of experiments you will be doing. Okay. So after doing the experiments, we have to check the result by statistical method. And here the method we are following is called as student's t-test. So how to do the student's t-test is after doing the experiment, you substitute the value in the formula what we have for t-test. So the formula for t-test is t is equal to x bar minus nu divided by s the whole divided by square root of n, where x bar is nothing but mean value, nu is nothing but true value, n is number of observation, and s is standard deviation. So I'll repeat the student's t-test formula. I'll repeat ma. So student t-test formula is given as t is equal to x bar minus nu divided by n x bar minus nu divided by s the whole divided by square root of n. So this we call it as t-test formula, and where x bar is nothing but mean value, and nu is true value, n is number of observations, and s is standard deviation. So what are things you have to do here is, first you have to do the thing and substitute the value in this test, and you have to check the thing. Well, you have to compare. We have a t table, and in that table I'll show you. So this is your t table. So what you have to do is, after substituting the value, the mean value, then true value, the number of observations, then standard deviation value, you have to find all the values, you substitute in the t formula. After substituting, you have to take this table. This table is a standard one, it's given already. In this table we have number of observations, degrees of freedom, 90% confidence level, 95% confidence level, and 99% confidence level. They have tested finally, and they have given us a standard. As in the periodic table we have standard levels and all. So similarly this is said to be a confident level, t value for different confident level. So confident level 90% they have given, 95 they have given, and 99 also they have given. I'll say one example. If the number of observation, 3 different titrations you are doing for the same thing. So degrees of freedom will be n minus 1. N minus 1 is nothing but 2. And if it is 90% confidence level, the value should be 2.92. And if it is 95% of confidence level, the value is 4.3. And if it is 99%, it is 9.93. What you have to do here is, the t value has to be calculated. After calculating, you have to compare that with this theoretical value given in the t table. That's the second point. Okay, so then what you have to do is, you have to compare the thing. After comparing, you have to justify that if the calculated value is found to be greater than the given t value, then the result is found to be significant. Then the result is found to be significant. It is clear? So I'll repeat the point once again. So in t-test, what you have to do here is, first what you have to do is, you have to go with this formula. The formula is nothing but t is equal to x bar minus nu divided by s divided by square root of n. Okay, you substitute all the values. After substituting the value, you take this table, and they'll be given all the things, whether it is 90% confidence level you have to check, or 95% or 99% they'll be giving. Okay, after checking the thing, what you have to do here is, you compare that with this particular table. And finally, how to conclude is, if the calculated t value is found to be greater than the value given in the table, the result is found to be significant. புரியுதாம்மா என்ன சொல்கிறேன்னு? ஸோ முதல்ல டி வேல்யூ சப்ஸ்டியூட் பண்ணணும். சப்ஸ்டியூட் பண்ணதுக்கப்புறம் செகண்ட் என்ன பண்ணணும்னா, நமக்கு அந்த டி டேபிள் கொடுத்துருக்காங்க. அந்த டேபிளில் நமக்கு வந்திருக்க வேல்யூ வந்து அதுக்கு கூட சேர்த்து நம்ம கம்பேர் பண்ணி பார்க்கணும். அவங்க கொடுத்துருவாங்க 90% கான்ஃபிடன்ஸ் லெவலாக 95 99 கொடுத்துருவாங்க. கொடுத்ததுக்கப்புறம் நீங்கள் என்ன பண்ணணுன்னா, செகண்ட் ஸ்டெப் என்னென்னா, நமக்கு கிடச்சிருக்க வேல்யூ இந்த வேல்யூ கூட கம்பேர் பண்ணி பார்க்கணும். சரியா? ஸோ தேர்ட் பாயிண்ட், வாட் இஸ் த கன்க்ளூஷன் வில் பி கம்மிங் ஃப்ரம் தேட் இஸ், நமக்கு கால்குலேட் பண்ண வேல்யூ வந்து இந்த வர்ற வேல்யூவை விட ஜாஸ்தியாக இருந்துச்சுன்னா, தென் யூ ஹேவ் த டைட்ரேஷன் வாட் யூ ஹவ் டன் இஸ் இட் டு பி சிக்னிஃபிகண்ட். அப்படி வரலைன்னா இட் இஸ் நாட் significant. You have to reject the result. Is it clear? So now I'll go with the thing, the problem. We can check the thing. Okay, so what's the thing given there is, if the mean of 9 measurements na enna meaning na 9 times பண்ணிருக்காங்க is 8.37 and the true value is 7.91 and the standard deviation is 0.71. Say whether the result is significant or not. I'll repeat the problem. So mean value கொடுத்திருக்காங்க, it is 9 observations க்கு 8.37 and true value is 7.91, standard deviation 0.71. So if you substitute the values, you get the answer as 8.12. 8.12 you are getting. And if you check the t table, so if the measurement is said to be 9. Okay, so number of degrees of freedom எவ்வளோ வரும்? 8 degrees of freedomக்கு அவங்க எவ்வளோ பர்சன்டேஜ் நம்ம செக் பண்ணால் 99% நம்ம செக் பண்ணுறோம். ஒன்றுமே கொடுக்கலன்னா நீ என்ன செக் பண்ணிடலாம்? 99% வேல்யூ பார்த்தீங்கன்னா 3.36, அதான் மேக்ஸிமம். ஓகே, ஸோ சின்ஸ் the calculated value is found to be greater than the value in the table, the result is found to be significant. It is clear? ஸோ நம்ம வேல்யூவை கால்குலேட் பண்ணிடுவோம். கால்குலேட் பண்ணிட்டு சிக்னிஃபிகண்ட்டாக இல்லை நம்ம அதை ரிஜெக்ட் பண்ணுமான்னு எப்படி பார்க்கணுன்னா, நமக்கு வந்திருக்க வேல்யூ வந்து அந்த டேபிளில் உள்ள வேல்யூவை விட ஜாஸ்தியாக இருந்துச்சுன்னா that is said to be significant. It is clear, ma? So I'll go with the next point. So this is something about t-test. Students, t-test. I'll go with the next one. Next one is called as, second test is called as confidence limit. Second one is called as confidence limit. Is it okay? So I'll say what confidence limit is. So what I mean by this confidence limit is statistical theory allows us to determine the range within which the true value might fall. நம்மளுக்கு இருக்கிற ட்ரூ வேல்யூ வந்து எந்த லிமிட்டுக்குள்ளே விழணும்னு சொல்லி இந்த கான்ஃபிடென்ட் லிமிட் வந்து சொல்லும். அந்த ரேஞ்ச் இஸ் கால்ட் as confidence level or confidence interval, and this interval we call it as confidence limit. I'll repeat. So the range can be determined using a formula what is given over there, and using that thing we can find what is the range of the confidence limit, and this limit we call it as confidence limit. And the formula for confidence limit is x bar plus or minus ts divided by square root of n. I'll repeat. So confidence level is given by the formula is equal to x bar plus or minus ts divided by square root of n. Okay, so this is a formula where x bar is a mean value, t is a statistical factor, s standard deviation, and n is a number of observation. I'll repeat. So confidence limit is a limit which gives the range of what we have to get, and if the range is okay, the answer is correct. Is it okay? So now we can see the formula. Confidence limit is equal to x bar plus or minus ts divided by square root of n, and x bar is mean value, t is statistical factor, s is nothing but standard deviation, n is number of observations. Okay, so with all this also we can see a problem. So what is the thing given in the form problem is a sample of soda ash was analyzed by titration with standard hydrochloric acid. The analysis gave 93.50, 93.58 and 93.48% sodium carbonate. Find the confidence limit within the range 95%, and standard deviation is 0.075. 0.075. So you have to find the mean. Mean value is nothing but, you know how to find mean. We have already seen. You add up all the values divided by, because 3 values divided by 3, the answer is 93.50. Standard deviation they have given, it's 0.075, and the t value for, because it is 3 titrations we have done, so if you take the t value, that is statistical value, how to take the thing is you have to take it from 2 degrees of freedom. It is given as 4.3. So I substitute all the values. The value is found to be 93.5 plus or minus 0.19. So if you add 93.5 plus 0.19 is nothing but 93.31. And the another one, if you do 93.5 minus 0.19, you get 93.31, and if you add the thing, you get 93.69. So within this range your value should come. Is it okay? So this is the confidence limit. So this is said to be the confidence limit. I'll repeat. So how to find the thing is the sample is given. What you have to do here is you substitute the standard deviation, mean value, and t value you have to take from the t table, that is statistical value. It is given as 4.3. You substitute all the values. The final answer will be 93.5 plus or minus 0.19. So from this what you can say is the true value will fall between the range 93.31 to 93.69. So you can check. So our value will be, the true value will be between this limit. So the limit can be calculated. It should fall within this limit. If it is falling within the limit, it is okay. Okay. So next we can see something about the third one. It is said to be Q test for rejection of result. So I think you are able to follow the first two methods. The first one is nothing but students t test. Second one we have seen is confidence limit, and third what you are going to see is Q test for rejection of result. So what you have to do here is you have to do the series of experiments. After doing the thing, one of the result may differ from the rest, and decision has to be taken whether the result is found to be rejected or it should be taken into account, and this is done by Q test. So experiment we have done, and after doing number of experiments we have to take into account which experiment we have to take and which and all we have to leave. Okay, so how to do the test is where we follow this procedure. First, the results are arranged in the increasing order. நீ என்ன பண்ணு, கொடுத்துருக்க நமக்கு வந்த எல்லா ரிசல்ட்டையும், ஃபார் எக்ஸாம்பிள் ஒரு டைட்ரேஷன் 5 தடவை பண்ணேன்னா அந்த 5 வேல்யூவையும் இன்க்ரீசிங் ஆர்டரில் வந்து அரேஞ்ச் பண்ணிவிடு. அரேஞ்ச் பண்ணதுக்கப்புறம் யூ யூஸ் த ஃபார்முலா Q வேல்யூ இஸ் ஈக்குவல் டு suspected value minus nearest value divided by largest value minus small value. So this is a formula for Q value. I'll repeat ma. So Q value is nothing but suspected value minus nearest value divided by largest value minus smallest value. This is a formula you have to use, and the Q table is given here. Using the Q table you can calculate the value, and if the value is coming higher, the result has to be rejected. Okay, previously we have seen if the value is found to be higher, it is said to be significant, but in this case if the value is found to be greater than the Q value given, then you have to reject the suspected value. நமக்கு எந்த வேல்யூ தப்பாக இருக்குமோ டவுட் இருக்குதோ அந்த வேல்யூ வந்து நம்ம ரிஜெக்ட் பண்ணிடலாம். இல்லை இதை விட குறைவாக வந்துச்சுன்னா you can take into account. Okay, so I'll repeat the procedure once again. Okay, I'll repeat ma. So first thing what you have to do is you have to arrange the values in the increasing order. After increasing the order, you get a value. If some value is found to be very abrupt, நமக்கு abnormal ஏதாவது வேல்யூ இருக்குன்னா அதான் என்ன வேல்யூ, சஸ்பெக்டட் வேல்யூ. ஸோ நமக்கு ஃபார்முலா என்னென்னா சஸ்பெக்டட் வேல்யூ மைனஸ் அதுக்கு நியரஸ்ட் வேல்யூ. சரியா, சஸ்பெக்டட் வேல்யூக்கு எதை மைனஸ் பண்ணணும், அதோட நியரஸ்ட் வேல்யூவை மைனஸ் பண்ணணும், டிவைடட் பை அது நமக்கு அரேஞ்ச் பண்ணியிருக்கிறது லார்ஜஸ்ட் வேல்யூ மைனஸ் ஸ்மாலஸ்ட் வேல்யூ. மைனஸ் பண்ணிவிட்டு என்ன பண்ண, உனக்கு வந்து Q வேல்யூ கிடச்சிடும். ஓகே, Q வேல்யூ கிடச்சதுக்கப்புறம் டேபிள் இஸ் given here, and that table you have to compare. Okay, if the calculated value is found to be greater than the Q table value, then the value may be rejected. This also I'll explain with an example. Okay, so this is the Q table. You can see the table here. So number of observation, if it is 4, the Q value is 0.76. If observation 5, the value is found to be 0.64. 6 it is 0.56. 7 it is 0.51. 8 it is 0.47. 9 it is 0.44. 10 it is 0.41. Okay, and with the basic of these ideas, bear in mind, we'll go with the problem. Okay, 5 determination of vitamin C of citric fruit drink gave the result 0.218, 0.219, 0.230, 0.215 and 0.220 milligram per ml. Apply Q test to see whether the 0.230 value may be rejected or not. So அவங்களே கொடுத்துட்டாங்க, கொஞ்சம் வேல்யூஸை கொடுத்துட்டு what they have asked is the value they have chosen, and you have to test whether that value should be rejected or it should be taken into account. சரியாப்பா, ஸோ அந்த வேல்யூ தான் நம்ம என்ன பண்ணோம்னா சஸ்பெக்டட் வேல்யூ, அதான் வந்து நமக்கு வருமா வராதுன்னு நினைக்கக்கூடிய வேல்யூ தான் நம்ம என்ன சொல்லுவோம்னா சஸ்பெக்டட் வேல்யூ. ஸோ சஸ்பெக்டட் வேல்யூ முதல்ல போட்டிருக்கோம். இதுக்கு ஃபார்முலா என்ன, Q is equal to suspected value minus nearest value divided by largest value minus smallest value. ஸோ நமக்கு இதில் சஸ்பெக்டட் வேல்யூ வந்து 0.230. ஸோ கொடுத்துருக்க வேல்யூவில் அது பக்கத்தில் இருக்க வேல்யூ வேறு, பக்கத்துலன்னா அதுக்கு நியரிங்காக இருக்கக்கூடிய ஆன்சர் என்னென்னா 0.220. ஸோ மைனஸ் 0.220 டிவைடட் பை இருக்கிற வேல்யூவில் லார்ஜஸ்ட் வந்து 0.230, உள்ளே ஸ்மாலஸ்ட் யார் 0.215. ஸோ இப்படி சப்ஸ்டியூட் பண்ணி இந்த ஆன்சர் வில் பி 0.67 milligram per ml. ஸோ இந்த வேல்யூ அப்படியே வச்சுக்கோங்க. ஸோ இதில் எத்தனை அப்சர்வேஷன்ஸ் இருக்குது, 5 அப்சர்வேஷன்ஸ் இருக்குது அப்படி தானே. ஸோ 5 அப்சர்வேஷனுக்கு எவ்வளோ வேல்யூ வரணும், 0.64 தான் வரணும். பட் ஆர் ஆன்சர் இஸ் 0.67. So what you have to do here is, since it is 0.67, we have to reject that 0.230 and others can be taken into account. It is clear now? Yes? I think you are able to understand what I am saying here. I'll repeat this problem once again. So 5 values கொடுத்துருக்காங்க, கொடுத்துட்டு a value has been chosen 0.230 and they have asked that this value has to be rejected or not. So we know we know the formula for Q. Q is nothing but Q is equal to suspected value minus nearest value divided by largest value minus smallest value. Okay, you substitute all the values, you get the answer is 0.67, and if you check the same thing in the Q table, the value is found to be 0.64. So what is the conclusion you have to come here is, because it is 0.64, our value is 0.67, the particular value 0.230 has to be rejected. Students, I think you are able to follow today's class. We can have a short recap. So what are things we have seen for today's classes? Two types of experimental errors. One is determinate, it's called a systematic error. Second one is indeterminate error, it's otherwise called as random error. Then the types of systematic errors, we have seen three types: instrumental errors, operative errors, and methodic errors. And the next thing we have seen is analysis of experimental results. There are three analysis. One is student's t-test, second one is confidence limit, and third one is nothing but it is called as Q test. So t-test, confidence limit, Q test. So students, I think you are able to understand the class what I have taken today. Continue studying. Thank you for listening.